Welcome. In this video we're going to explore blade adjustment in ZebraCut. That will allow us to account for overcutting and undercutting caused by the physical geometry of our cutting blades. So first let's define terms. So if I have the bed of our machine in blue, we have our material in yellow, and we have the location at which our blade is going to be sent to. The XY coordinates is represented by this green arrow. Then we have an example blade. Now on this particular blade, you'll see if we send this blade to a particular location, that it will actually cut the top of the material a little bit further than where we sent it. So that distance there would be called overcut. Conversely, we may have undercut based on how the blade is put into our holder. So at the bottom of the material, this is a particularly thick material, we would have undercut, that is, the material is not fully cut at that location. That might cause our material to not lift out cleanly when we cut parts, or it may be that we have missed threads when cutting fabrics, for example. Now, overcut and undercut are essentially opposites, and we can use them to account for each other. So, for example, to account for overcut, we would need to reduce the distance we cut slightly, and that would be done by introducing some undercut. Conversely, to account for undercut, we would want to add some overcut. So in this case, we'd want to increase the length of our lines on the edges here. This will all become clear when we have a look at some examples. So let's go to ZebraCut, and we'll have a look at these examples here. Now I'm going to try to assign a knife tool to these parts, and then I'm going to look to add blade adjustment. So to do that, we're going to add a configuration, and we're going to add the blade adjust configuration. Now if you don't have that blade adjust option there, you'll need to add it in your tool library. You can see how to do that in a separate video. Now blade adjust has a large number of options. We're just going to focus on the most important ones to start with, which are start and end adjustment in millimeters. Now if you want to introduce some overcut, you enter a positive number. If you want to introduce some undercut, you enter a negative number. So undercut would be very commonly used for tools like a pizza wheel, where it's a very large radius or large diameter tool, and so just by its very nature it will inherently overcut. So to account for that, we need to undercut our geometry. So I'm going to introduce a negative number here, and so we're going to introduce some undercut to account for the blade, which inherently overcuts. And just change one or two other settings to demonstrate a few things to you. So we're going to have -10, -10, and we'll run a preview of that to see what effect it has. So you'll see what's happened is for every side of this square we've reduced the start and end of the line by 10 millimeters, and so we don't actually cut right up to the corners. However, because the blade will inherently overcut, we will automatically get corners which join. And that will avoid us cutting outside of the square, for example. The same on our circle. Now this shape here is interesting because it is a series of straight lines and then curves, but you'll see only one of them is being picked up. Now we need to look at why that is, and a key parameter to consider is the minimum angle. So the minimum angle here was set to 30 degrees. If we drop it down to say 20 degrees, we will catch all of those corners. And you'll need to find the right settings for your geometry and your tool. So there we go. If we put that down to 20 degrees, you'll see we actually do the correct undercutting on all of the corners of that shape. Similarly on this shape here and on these two nested squares. Now this last shape is an interesting one because we've asked for 10 millimeters of reduction on both the start and the end, so 20 millimeters of reduction in total. However, we look at these facets on this square, in total, that is only 14 millimeters long. So we actually don't end up cutting those facets at all. Now that's probably worse than, in fact, overcutting them to begin with. So what we can do is we can ask ZebraCut to just plunge the blade in the center of each of those facets. Now this kind of just plunge, essentially no XY movement, is what we call a microcut. And if we go into the options, you'll see we can enable these things called microcuts. And any cut, let's say below, well, we're doing 20 millimeters of adjustment, so let's add 20 millimeters. Our microcuts will be for any lines below 20 millimeters, where it'll just take the pizza wheel to the center of that line and just plunge it and then lift it, so no movement. Well, there'll be a very small movement. We'll do a 0.01 millimeter line, so almost nothing. So that's a microcut, and I'll just show you the effect of that. And if we run that, you'll see we now get microcuts here. I think perhaps because this is quite short, I'm going to microcut that. But if I just put that back down to maybe, let's say, 5 mil, we should end up with, yeah, there we go. So we're going to microcut on the facets, but we are going to make sure we do a long cut on this side here. So there is an element of experimentation required or measuring required on your blade to account for its properties correctly. But microcuts will allow you to essentially do a plunge cycle on very short curves like those. So that's dealing with overcutting by introducing undercutting. Let's now do the reverse, and let's have a look at how we can get ZebraCut to automatically add some overcutting to our geometry. So let's just try to overcut by, let's say, 4 millimeters at the start and the end, and we'll leave all of the other parameters the same. So if we now zoom into these corners, you'll see we have overcutting occurring on all of the corners of this square. On the circle, we have an interesting phenomenon occur. If I take this preview curve and explode it, you'll see I actually have two curves, two motions. And if I can select the right one, I'll just move it slightly. You should be able to see that these curves actually overlap. So the way that ZebraCut is able to add overcut to this circle is by going around the circle more than 360 degrees. We go around the circle essentially slightly more than once in order to ensure that we do get a completely cut circle. And notice those extensions are actually curves as well. You can see that more clearly here. If I make the overcut slightly longer, you'll see this more clearly. So if we overcut by, let's say, something crazy like 20 millimeters in both directions, what you'll be able to see is that actually where we have a curve, the extension is also a curve. Where we have a straight line, the extension is also a straight line. So ZebraCut is intelligent about how to extend your curves. Now, this is an interesting case. So we have this shape B, and we are doing overcuts to the starts and ends of all lines. However, you'll notice that we're now cutting into the center of this B shape, and that obviously would be bad for the final parts that we're cutting. So if we go back to our options for blade adjustment, we see there are options here to whether or not to accept inside and outside. So since this is an exterior contour, we're going to turn off accepting inside cuts. So if I now preview that, you'll see that we do no longer get overcutting into the interior of our shape. Instead, what you'll see is a reverse cut. Now what that means is the blade essentially stops short of our corner, it then lifts, rotates 180 degrees, and plunges here at this point and goes back to where it was originally cutting. Now this works very well with the kind of blades we were looking at the beginning of this video. So with these kind of triangular shaped blades, you'll find this reverse cutting to be a very useful feature indeed. But there we go, so ZebraCut will intelligently not cut within your shapes. However, it does mean that you need to consider where your geometry is. So you may need to have a different layer with your internal geometry on a different layer. So if we make this internal, just clear the preview and put this onto our internal one. And now we'll take our tangential knife and we will add our blade adjustment. We'll give it our cutting here, and we will accept inside, but we won't accept outside in this case because this is the interior. And you'll see it's now done reverse cuts on all four lines in those cases. Okay, and similarly we should put this onto our internals. And you can use the layer by internals preparation step to automatically put your internal geometry onto your internal layers. There we go. So again, here in this case we've done no interior cuts. You can of course choose to reject both inside cutting and outside cutting, and that will force ZebraCut to do reverse cuts on every single line. And now that will of course be slower than cutting off into waste, but you know, if that's what you'd like to do, you can of course make the machine work harder and produce more precise parts. So there we go, those are the options for blade adjustment. In addition, you've also got this minimum segment length. That can be used to reject cutting very, very short segments, particularly if you have very dense polylines where actually the line segment is so short and your blade is so large, it doesn't actually make sense to even try to cut these lines. So if you find yourself in that circumstance, you can avoid cutting lines of very small size. These algorithms work best with joined geometry, and so this configuration will automatically undertake a join. If you want to disable that for any reason, you can of course do so, but we would recommend that you undertake a join as part of this step. Finally, if you have curves which are not closed, you can still blade adjust them, but you will need to ensure that you have this option here turned on. If you have any questions on this, my advice would be to explore. You obviously can't break anything if you're just running a G-code preview, and you can see how this will perform using the preview as we've been doing through this video. But if you do have any questions, there is contextual help here. If you just hover over that, it'll remind you what each of these options do. But say if you do have any questions, please do get in touch with technical support. Thank you very much indeed.